going to discuss about some network security. So first of all, I will going to do some recap of the previous classes, and then I'm going to do forward things. So yesterday we discussed about some communications and network security part. So mostly we have covered some network fundamentals yesterday. So right now we have discussed the previous classes agenda which we have discussed yesterday. So we discussed about some OSI layers. We discussed about TCP/IP suite, devices and communication components, network topologies, IP version 4 and IP version 6, wireless networks, and ports and protocols. So we have discussed all those things in the depth, all those things. So we discussed about some network security. What is the network security? What is the requirement? Network security. What are the network security analyst jobs is doing it? And we discussed about some OSI reference models. So it was came in 1984, and these are 7 layers models. So we discussed about some hardware layers, software layers, and part of the OSI models we discussed. And we discussed about the OSI layers, each and every layers, what is the use cases, and how the 7 layers or OSI layers network communications is going on. So I recommend that you should understand and memorize all those 7 layers, which is very important for your networking career as a cybersecurity consultant. It is very important for you to how the communication is going on. So we have routers, we have switches, we have modems, we have cables, we have software technologies. So all those things, the combinations of the OSI models. So we discussed about application layers uses, presentation layer, how to present the data, how the sessions is going to be established. So before it is going to be communicate with the destination server or destination devices. So the session is going to be established. Then we discuss about some transport layer, how the transport layer TCP and UDP is going to be working. We discuss about all those things. And we discuss about some network layer. So the network layer, we discuss about some routers and firewalls, the devices of the WAN technologies. So your packet is going to sending the outside of your networks to the communication with the different routers and switches. And we have seen some command line tools like trusted command we discussed. Okay, so how you're going to be see that your traffic is traveling from different routers to reach the destination. We discussed about some data link layer. So the switches are working on the data link layer. So the MAC address is very important, and the IP address and MAC address is going to be binding into the network layer, the data link layer for the switches point of view. We discuss about some physical layers. So it's all the cables, like for fiber optic cables, we have UTP cables. For all those cables, the uses this comes under the physical layers. Then we have OSI or layers protocols. We discuss about the different layers, different use cases, what are the different protocols, what are the different things is there. So suppose somebody will going to ask you the question, where is which layer the segments are going to be created? So segments are created into the transport layer. Somebody will going to ask you, where is the packets going to be created? So the packets are going to create into the network layer because the routing and switching. So the routing has been done on the packets. The packets will be sending to the destination. Somebody is going to ask you the question, where is the frames are going to be created? So frames are created on the data link layer. Okay, and what are different type of cables going to using it? So you're going to say how we're going to use the fiber optic cable, single mode and multi-mode, and we have UTP cables for the networking. So we discussed about the length cable, the UTP cables, which is the range of the 100 meters, and the UTP, the fiber optic cables range is very high. Okay, so these are segments, packets, frames, and we discussed about the sessions. So session going to be established. So the RDP session, okay, remote desktop procedure. So we have port number 3389. Suppose I'm going to do MSTSC, so the RDP thing is going to be working. Presentation layer, suppose you're going to encrypt your file and going to decrypting your file. So encryption comes to the picture in the presentation layer. Yes, please. And questions you're going to be asked at the same time, so that I'm going to help you out. An application layer, suppose you're going to sending an email to somebody else, so the application layer comes to the picture. So just the segments, frames, packets, and the cables, and the sessions, presentation things, application things, just try to remember all those things, so that it is going to be very useful, and it will going to be covered once we're going to be doing the Wireshark, the packet analyzer tool. We're going to use some Nmap tools, and we're going to use different type of tools for the cybersecurity point of view later on. So the another thing is comes to the picture. We discussed about some TCP/IP model. So the TCP/IP you going to say that is a TCP is a protocol where the end-to-end communication going on. So we discussed about some command line tool, like we have netstate -p, netstate -s, netstate -p commands. So that TCP connection established, not established, all those things will be there. So it's a three-way handshake model, first of all. So the sync acknowledgement and acknowledgement, this is things, and then the connection will be established. So it's a end-to-end communication, source to destination, and it's a guaranteed your packet will be sending to destination, because it will going to be sending the acknowledgement. Suppose I'm going to do here then, and then I'm going to write down the specific IP address of my any destinations. So it will going to be come that where is going to be connected the system or not connected. So it is going to provide you acknowledgement. So the question will be coming at interviews that please tell me something about the three-way handshake of the TCP protocol, and what is the difference between the TCP and UDP. So overview about the UDP. So user datagram protocol is faster than the TCP. So UDP protocols don't need to providing the acknowledgement. Suppose you're going to download the movies or software from the uTorrent. So the uTorrent you want to download, you're not damn sure that it is going to download it or not download it, because it is not going to provide the acknowledgement, the end-to-end communication. And suppose you're going to downloading some files from your source to destination. Suppose I'm going to download from the Rdp server or different servers. So it is going to be end-to-end communication. It is going to provide the acknowledgement that it is going to be download all things. So the UDP is faster than TCP. So these are some basic difference you need to understand, because once you're going to do Wireshark or any different tools of the cybersecurity, this is going to be very important to understand how the communication is going on, and what are the protocols, what is the port numbers of the protocols, what are the services going on. So this is very important for your entire career of the cybersecurity. So this is the UDP header is 8 bytes. So we comparison of OSI model and the TCP IP model discussed here. So the OSI model and the TCP IP model, you just going to be remember all those 3 to 4 points, so that once you're going for the interview, you're going to be say that, sir, we remember, we know that what is TCP IP model, what is OSI model, and this is going to be working. So we skip the questions, and then we discuss about some IP addressing schemes. So you need to understand some basic fundamentals of the IP address, like private IP address range, public IP address range, what is DORA, okay, the DHCP range we discussed about, okay, the DORA is discover, offer, and request and acknowledgement. So this is a range of 169 series of the IP address is going to be working. We have a range of IP address like 1 to 126, 128 to 191, 192 to 223, 224 to 239, and 242 to 54. So this is the IP address range class A, class B, class C, class D, F, class D, E. And you need to understand the public IP address, private IP address range. You need to understand the subnet masking, okay, wildcard masking, subnet masking. This is the important things. And we discuss about some IP version 4 and IP version 6. So at least 3 to 4 difference you need to be learned about the IP version 4 versus IP version 6. It is not going to be asked anybody, but it is very important for your security career. So you need to understand all those things. Then we're talking about some netting. So network address translation. So we have checked the practicals on the SonicWire demo. So how you going to be create the policies for the network address translation. So we have netting and PAT, network address translation, and port address translation. So this is the PAT is different thing, NAT is different thing. Netting on we want to do going through the IP address. So suppose this is a host is there, and this is my private networks. I'm sitting from my systems, and if I'm going to access this particular server, so I have to reach to the company router, and company router is going to be your public IP address converting to your private IP address and sending the request to the server. And server is sending with the private IP address with the router, and it is going to convert into the public IP address and sending to the request. So however, I'm going to use some VPN, Open VPN or Cisco AnyConnect or whatever the communication channels we're going to discuss later on. We have static IP address and we have some dynamic IP addresses we discussed. So static IP addresses are those IP addresses where we're going to be static all the time. So there's not going to be changed. Suppose you are going to provide a static IP address on your WAN links. What do you mean by WAN links? You need to always provide the static IP address to your interfaces of your firewalls or routers of your WAN devices mostly. Why it is? Because if it is the IP address is going to be changed, then there is no communication thing going on. So static IP address, where you're going to be manually assign the IP address to the devices on the interfaces so that it is always remain same. And dynamic IP address are going to be getting from the DHCP end. So this DHCP is going to provide the IP address dynamically. So because they have the lease of 7 days, so after the 7 days, the lease is going to be expired, and then the device is going to get some different IP address. So this is the basic fundamentals, basic understanding about the IP address, static and dynamic, DHCP, DNS. This is the requirement, my dear friends. Circuit switching is not going to be using right now. So we have circuit oriented because in the previous offices, you have going premises and office, they're going to use some circuit switching and packet switching for the conferencing calls. But right now, the technologies are going to be changed. You have seen some different type of conferencing things and voice over IP things, the circuit switching things going on. So yes, this is the outdated things, and we don't need to discuss too much about it. Yeah, virtual circuit switching, so we're going to discuss about later on in the routing platforms of the OSPF or on anything like that. Bridges are not going to be used right now currently, so we're not going to be waste too much time into the same. So switches, we already know that. So first, once we're talking about the switch, suppose you are a security consultant for the company, and company will say that, hey, come on, I will require the 5 switches. So what does it mean? You, as a security consultant, cybersecurity consultant, you would ask to the person that what type of switches we require. It's a manageable switches or unmanageable switches, first of all. So the use cases, what type of use case into the company? Company will say that we need to be maintain the switch, we need to create the VLANs into the switch, we need to be check it out what are the interfaces, how much speed of your interfaces. You're going to check it out, the backup, you're going to take the backup, you're going to take the restore, we're going to change the traffic. So we require some manageable switches. Suppose company will say that we need to use we have some access point or we have wireless devices, we're going to be connect. So instead of you're going to purchase a manageable, non-manageable, you're going to purchase a power on Ethernet switches. So a different type of switches, which is all the ports are going to be generate the 12 voltage of the electricity. So this is the access point, or access point doesn't require the power connection same time. Only the Ethernet cable is going to provide the power of 12 voltage same time. So this is the switches and routers or whatever the appliances or the device is going to be purchased in the company. It should be more important that check out the use cases. What are the use in the company? And then you're going to recommend the solution same time. So if you're going to connect only the devices, okay, so that you require the non-manageable switches, only the device is going to be connected. But if you would like to change the way to transport, or you're going to change the communications of all the interfaces, so you need to create some VLANs, virtual LAN inside the switches, and then you need to acquire the manageable switches. So we go talking about some switching part later on, and with routing part and switching part, we have separate story of CCNP. We discussed later on, but you have some basic fundamentals I'm going to discuss right now here. So switches are the one broadcast domain. Okay. So we need to understand the broadcast, multicast, anycast. So this is the basic fundamentals you need to be understand over here. So it is basically whatever the MAC address of your particular device. So it is going to be MAC address, and the IP address is going to bind into the MAC table, into the CAM table, into the switches. So constant address memory. This is the table name is there. The chip is inside the switches, and the switch is going to maintain the IP address and the MAC address of the devices. Suppose this computer is going to be communicate with a particular system. So it is request going to the switches, and the switch is going to be say that yes, this is the your LAN devices or it's a WAN devices. Suppose this switches are not going to find out the IP address of the system. So it is going to send the traffic to the router center. Okay. Then we have the routers. So we discussed about the routers and the firewalls. These are some layer 3 devices or the networking devices. So your packet is going to be outside as compared to the switches, which is working on the LAN devices. Okay, local area networks. So it is going to be connecting with your office environment all the time. But once you were talking about some your if you're going to do the google.com or whatever, so the request is going to be outside. So the routers comes to the picture. We have gateway, same things, and the firewall. So we talking about firewalls, we're going to do some separate classes for the gateway level firewalls. We follow it to or checkpoint and Tronic Wall. We have different firewalls in the market right now. So unified threat management, next generation firewalls. Okay, and we have different type of features like sandboxing environment. So all those things we're going to discuss in the separate class for the routers or firewalls. We're going to doing it later on. We have proxy servers. So the proxy servers are intermittently between clients that need to be communicated. So we're going to be creating the proxy servers before, but right now we have different technologies we're going to use in it for the URL filtering. So all those URL filtering, malware protection, data loss, we have separate devices available right now. DLP solutions, IDS IP solutions. So this comes under the firewalls. LAN devices, you're talking about some 100-meter range of the LAN devices. So your cables or UTP cables are going to be using it also. So WAN is what we have communication from the distance is very high. So we have dedicated links. So you're talking about some broadband, you're talking about some lease lines. So broadband is basically your home locations. You're going to be taking a line from the ISP. But the lease lines are working for the companies. It's a dedicated line to your ISP, to your office, your premises. Okay. So this is the WAN links we're talking about here. So we have right now we have copper copper cables going to be connecting, and second way to fiber optic cables are going to be come to your office. So we have two technologies right now. The fiber optic cables are more famous compared to the copper connections. We have common network cables. So we discussed about some coaxial cables for your cable TV or something like that. This is going to be working. So this is the very old cables we are not going to use in our network premises currently. But the unsealed twisted pair UTP cables are going to use right now. So we have Cat 5, we have Cat 6, and we have different color coding, all those things. Just so the basic idea about the networking, please, you need to be take care. And we have fiber optic cables. So this is the single mode, multi-mode cables, and this is a very fast convergence because your communications with the light is going to be going in this particular cable inside the cable. So it's fast communications, very reliable communications, and end-to-end communication is faster. So right now, fiber optic cable is more famous as compared to the untwisted cable. So UTP cables are mostly used into your LAN environment, switch to your systems. So we have straight cables, we have crossover cables. So these are some different types you're going to be create the UTP cable. But fiber optic cables are mostly you are going to using into the ISP vendors on the WAN links. Okay, so we have some braid copper shield, we have outer jacket, we have copper connector. So this is the things like you want to be no one going to ask you into the things, but you have basic understanding requirement of the cables. Okay, because you are a cybersecurity expert. So once you go to consulting, so you have idea about what is the UTP cables and what is the color coding and state cable, cross cable, all those things you need to be understand. This is fiber optic cables. So you have seen that we have single mode and we have multi mode. So small glass core, we have large glass core, and this is the different type of locations, different type of distance is going to be covered. So this is going to be understand. So we have ring topology. So we ring topology, we have star topology, we have mesh topology, we have plus topology. So this is not going to be using right now, but it's not star topology. Yes, it is going to using it. So we have one centralized devices like we have route, we have switches, and we're going to connect all your systems from the one switch. So suppose any port which goes down, so all other ports are working right now same time. Analog transmission, digital transmission, so the basic electronics is there, so we don't want to cover. And we have a separate class for the wireless technologies, so we're going to cover some standards of the wireless as well. Okay, so Wi-Fi product things we're going to discuss about the CDMA, everything. So this is your mobile devices, okay, CDMA and GSM chips. Okay, so CDMA is all those SIMs are blocked right now. So you are guys using the GSM mobile chips SIMs in your mobile devices. So we have authentication protocols we discussed about into our Wi-Fi technologies. Okay, so we're talking about right now the networking security and penetration testing and hacking. So what is network security, penetration testing, and why the hacking things has been done? So the matter of fact that suppose you want to do the penetration testing phases, so we information gathering. So we have some separate plan for the same. You are working in a company, and company will say that, hey, come on, could you please do the penetration testing for the company? So what is the first thing you're going to doing it? You're going to gathering the information. So we discussed about earlier, we have active assessment, we have passive assessment, we have inside assessment, we have outside assessment. So this is all about the inside assessment. You're going to working in a company and we're going to do penetration testing. So you're going to information gathering. So you required different type of tools like Nessus, Wireshark, Nmap, Metasploit. So we have different tools we want to using it to gathering the information. So we have Kali Linux environment. We discuss about all those tools. What other tools are for information gathering into the security point of view. Okay, they are not talking about some gathering the information, so collecting and examining key information about an application and its infrastructures. We go to reporting, provisioning and comprehensive report of deep analysis and recommendations on how to mitigate the discovered vulnerabilities. So how are you going to reporting the things? Discovering vulnerabilities, you want to find out some vulnerabilities inside the networks. So this is security testing methodology is planning, gathering information, reporting, and discovering vulnerabilities. So these are the 4 phases. Just going to take a screenshot of the picture and we're going to memorize that penetration testing phases and your understanding network understanding fundamentals of the security. Then we're talking about some different type of ports. So ports and overview is, so we, first of all, you need to understand here it is well-known port range. So 0 to 120, 1023 is a well-known ports. Okay. And 1024 is to 49,151 is registered ports and 49,152 is a dynamic port. This is a private high ports and this is a range. So mostly you want to encounter the issues or you want to work on the 0 to 1023 well-known ports. So suppose somebody will come to ask you what is the port number of HTTP, HTTPS, DNS, FTP, Telnet, SMTP. So just all those ports you want to be remembered. Okay. So this is SMTP port number, DNS port number, SMTP port number, Telnet port number, okay, SSH port number, FTP port numbers. So this is the requirement because once you're going to working on the different type of networking devices or security devices or application security or cloud security, network security. So this is the ports will be coming same time. And we have ports communications we discussed about yesterday that Oracle and we have STD, SDPS things we discussed about how to communicate things going on. So we have attacking ports and gathering information. So network discovery. So we have net discover commands. We're going to be using it into the Kali Linux environment once we're going to doing it. Okay, so this is the nmap command for the technical information of your IP addresses on a class. So ports and protocols working. So how the ports? So we have discussed right now the different type of ports and what are the use cases. So first is the ICMP. Since IP does not have a inbuilt mechanism to sending error or control messages, it depends on the internal control protocol ICMP to provide an error control. Suppose I'm going to do right now ping. Okay, this is the protocol. This is the things I'm going to doing it ping and cisco.com. So I would like to know that what is IP address is what is a protocol at the back end. The protocol name is ICMP protocol. This is the protocol ping utility using the ICMP protocol. This is what we discuss right now. So it is used for reporting errors and management queries, and it's error messages and operation information. So there's a ping utility using the ICMP packets. And once we're going to do the Wireshark, we're going to using it. So this is also the ping request will be coming same time. So we have Wireshark and Nmap we're going to do in the separate classes later on. So the basic fundamentals you want to understand that ICMP protocol for the ping utility, and it is going to provide an error controls. What is error? Suppose if you want to ping to the specific IP address and you want to get the request timed out. So this particular system is not available. So what does it mean? It means that it's going to provide an error control used to reporting errors and management queries, sending errors and control messages. So ICMP protocol will going to sending the request, whether it is up or down, the system is available or not available. So suppose host A, here is a packet of B and sending to the B. So right now, if it is not reachable, suppose the interface goes down, so we're going to check it out from here that ping this particular IP address and it's not reachable, it's ICMP protocol working. Then we're talking about the IGMP protocol, so Internet Group Management Protocol. So ICMP versus the IGMP protocol. So IGMP is Internet Group Management Protocol, is an internet protocol that provides the way to internet computer to report its multicast group membership to adjust routers. So multicasting allows one computer of the internet to send control of to multiple end computers. So it is IGP protocol is basically used for to sending the packets to different destinations and group of computers same times. So suppose this is your multicast source and this routers are there. So the IGMP protocol sending the request to everyone. Okay, not just to keep silent. Keep IGMP report I want, IGMP report I want. So all those this particular router is sending request to everybody that yes, this particular server is not available right now. We have ERP address resolution protocol. So suppose I'm working on my system. So how to check it out? What type of ARP MAC address or what are the things communication going on? Okay, so going to CMD and type the ARP minus A command is going to be using for your what are different type of MAC addresses communication with a specific IP address. So suppose this is the internet addresses and this is my system IP address is there, and this is the physical address of my system, and it is going to be allocated by dynamically. So ARP table will tell you that what are the different IP addresses and what are different physical addresses are, and what type of communication is static or dynamic is there. So interface 192.168.159.1, and this is the what the different IP addresses is there. So IP address and the MAC address going to be bind. We're going to check it out from the ARP. As well as if you have more going to find out with this things like that ARP, and then going to provide the command ARP. So ARP display current ARP entries by the allocating the current protocols data. If enter address is specified, the IP and physical address for not only the specified computer are displayed. If more than one network interface uses ARP, entries for each ARP tables are displayed. Okay, so this is the same thing we're going to doing it. So suppose ARP minus A, then we're going to do ARP minus G. The same thing is going to be showing it right now. And then B displays the ARP entries in the verbose mode. Okay, ARP minus D deletes the specified Ethernet addresses, and minus S is different things. So different functionalities altogether. Okay, so you're going to trying it from your right. If you would like to check it out, the physical address and the MAC address of the devices, whether it is static IP address taken or whether it's a dynamic IP address taken. So all those entries, ARP messages are going to be showing it here. Okay, so this is my system. It is going to physically address this one, and it is dynamically allocated. So this is all those IP addresses are going to be allocated what type of static or what dynamic is this. Okay, so we discussed about address resolution protocol is a network protocol used to find hardware MAC address of the host or IP addresses. Okay, so ARP used on Ethernet LANs because hosts that want to communicate with each other and need to their respective MAC addresses is there. So it is request of the protocol to ARP request messages are used to request the MAC addresses, while ARP reply messages are used to send request MAC addresses. So this is this system is going to be sending the request to this particular things, and then this is going to be checking the proxy ARP routers if things are there or not. Okay, so it is the different systems MAC addresses you want to getting the ARP reply. Then a very important tool protocol like we have TLS, transport layer security. So no one going to ask you that what is the ICMP, what is IGMP, what is the ARP things, but you have basic understanding requirement because once you're going to do some network analyzer, packet tracing things, you are working on the Kali Linux environment. So the things are you are in front of you same time. So if you have understanding, the basic understanding, what is ICMP, what is ARP, what is IGMP, so you're going to work very efficiently and accurately. For transport layer security, TLS, transport layer security, and it's now the depreciated procedure secure socket like SSL are cryptographic protocols and designed to provide communications security over the computer networks. So basically, it's a TLS or the SSL is basically is a secure protocol. It's a cryptographic protocol. Suppose you are here right now, your client, and you sending a request to sync messages, sync acknowledgement, and the sync acknowledgements. The server is sending a request against acknowledgement client hello messages, and this particular sync acknowledgement sending request to server hello certificate server hello drawn, and this particular certificate is going to be checked out, and the changes and change cyber specific finished, and then the combination will be going on TLS. So the matter of fact that suppose you are a sender and your receiver, I want to send you a secure email. These are the options I support. So this is the client is going to send an email to the server. The server, what happened? Server, okay, you will connect this. So this TLS packet, okay, this is going to be sending to the client, and the certificate is going to be check it out from the here's my security certificate and key. Okay, this is going to be sending to the client, and this is the same client is going to check it out whether the certificate is valid or not valid, and then sending the message to the again to the particular server. So how the things going on, all those things. Suppose I am working on a Mozilla. I'm going to showing it out. Okay, so suppose we have this particular website is Kadat Systems. Okay, I'm just going to send to you for the downloading things. So suppose this is the websites. Okay, so what I'm going to do, I'm going to download this particular thing. So suppose get security edition. So my request is sending to the server because I'm the client. I'm required this particular things. So I request to the server, please allow me to download this particular security edition of the pair systems, operating systems. So the same TLS thing, suppose I'm going to go here, and then I'm going to check it out here, and and this is the verified, it's let's encrypted. Okay, so this is the encrypted things, the lock is there. So it's HTTPS things is all there. Record more information on the same, like certificate things or what. Okay. So first of all, we're going to go into security part, and security part, first of all, what we're going to check it out. We have to check it out. This is the connection is encrypted. It's a TLS, transport layer secure. Okay. TLS and the SSL 384 to 56 bit is there. The TLS 1.3 version is there. First of all, this is a technical, it is a secure communication. So this is the things which we discuss right now. So it's a secure communication with the server. Okay. Client to server is secure communications going on. Okay, We require more information on the same. Go to certificates, view certificates over there, and then we talking about this is the common name for systems, and then we talking about some digital certificates of the particular thing. So the DNS name is there, and the public key, this is the modules is going to showing it right now. Okay, and this is the certificate, PAM certificate. Okay, so this is the certificate going to be downloaded over there. This is the certificate, PAM certificate, or whatever. Okay, so we have manager.msc is there. So you're going to be using the command line tools at your systems, and then check it out the different type of certificates installed on your system. Okay, so this is the certificate list. Suppose I'm going to go with personal, and the certificates is there. This is the certificates: MS Origin Access, MS Organization Access. So suppose we have some Mac certificate, we have SIM cards, so we have third party root certificates, we have Active Directory certificates, enterprise tags. So we have different type of certificates are already there in your systems. This is just take a look here. We have AAA certificates, counting, authorization, all those things. We have Centrum, we have all those things. This is by default installed on your systems. So if you're talking about some website point of view, you need to check it out, the certificate is installed or not installed on your system. So suppose we're talking about a hotspot, okay, we're talking about some Verizon, okay, different things, VeriSign certificates. So what happened? We're going to double click on the same, and then we're going to check it out the verified from 11/8/2006 to 2/30. So this is the certificate, is trusted certificate, and it is valid from this date to this date. And then the version number, serial number, signature, algorithm. So these are the digital signatures, digital certificates. You're going to be check it out from here. Okay, and the certificate name. So the first words. Yes, this certificate is okay. Certificate status. So you just going to check it out whether your certificate is there on your client system. So in this communication we discussed here right now, this is my sender. So this is my client systems. I requesting to the server to please send me the request. I require the downloading the file systems for my system. So the server is going to send in the key that yes, you can to download, but we require some certificates. So do you have certificate installed on your system? So you're going to first of all check it out the certificate is installed or not installed. And then it is going to be communicated with the server. So the server is going to be allowed. So we have trusted people, so we have different certificates. So this is a default certificate going to install. But once you want to talking about some your open VPN or VPN setup. So this VPN of your company is not going to be installed. You need to install it manually. Okay, this is the OPPO. This is Open VPN. Okay, so this is the Open VPN. Once you're going to install it, and then the Open VPN certificate is installed. So this certificate has expired or it's not yet valid right now. So why it is? Because it is expired on 9/26. So right now the Open VPN is not going to be working in the system. Okay, not going to be communicated. And this is the version number 3 and SSH signature version is RS7 S1. And this is the valid from the valid to, and there's all those things. Suppose I'm going to communicate with the same, so it is not going to work. Okay, so this certificate has expired or is not yet valid. So already we know that this is the date is already missing, so it is all saying right now this is not valid certificates. So issue statement: any use of the certificate contribute acceptance of DSP, CPS, the rank party, or limit probability. So the matter of fact that we need to install certificates to communicate with the client to server communication and secure communication. That is why the TLS comes to the picture. So why it is the non-repudiations? The non-repudiation means that suppose I'm going to ask the client that I want to install this particular operating systems. So after that, suppose is any forensic investigation is going on, and I'm not going to deny. I have not sent the request because the request is going on and the TLS certificate is installed and your communications logs will be there. So I cannot deny that I didn't send any type of request. Okay. So your IP addresses, your certificates, your communication, your logs, everything we're going to suggest that yes, you have done this activity. So mostly the hackers are going to, compromise them TLS certificates, something like that. So this is that is what this more communication and this is more secure things we're going to be creating it. So it's more complex things if you have to check it out over there. So it's ST256 with RSA encryption is there. So what this means, suppose this is a key. So this is the SSH key is there as calculator. So SSH256 is there. Okay. Suppose I'm going to do one more thing for you guys. Google, and then I'm going to check it out the hash calculator. Hash calculator. Okay. So this is a hash calculator, and then I'm going to using it. Suppose SSH256. This one, okay. This is the certificate we're going to discuss right now. This one. Okay. So how complicated it is, how complex it is. Okay. Suppose I'm going to write now. This is cyber security classes going on. Okay, suppose I have write down the plain text. It is right. So this is the cyber security classes going on right now. So this is the SSH256. So this is what we are looking for, it like SSH256. So how complicated? I would like to show that if you're going to do the hashing, so how complicated it is. So this is simple thing. This is cyber security classes going on, and algorithm is we taken 256, and then I'm going to hash this one. So this is the value this is coming. Suppose I'm going to send this value to you, so no one going to be recognize this one because it's already encrypted. The hash value is going to be different things. So plain text to the encrypted, okay, hash. Suppose we're going to do some more as to 384, more complexity. I'm going to using it. So this is the things. It's more complex. 384 complex. If you require some more easy things, do MD2, and then it's very small things. Okay, this is the code will be coming. So how complex you're going to create into the value of your certificates. So this is depend on the hacker. So hacker, it will take lots of time to hack this particular value. So I'm just going to be sending to you this particular link. Just once you have little time, go for it, and let me know if you're facing any issues. Okay, then we moving again to the slide. Okay, so this is the TLS we understand. Yes, we have telnet, the port number 23, and the command Nmap. This is the command line tool we're going to be using it. So this is all those things will be coming. So it is going to be access the remote connections of your system. So mostly what happens, guys, in our real world, you're going to install the PuTTY software in your system, and then we have telnet. So once you click on telnet, port number 23 is there, and SSH is port number 22. So I'm just going to go telnet and provide a specific IP address. You're going to get in the remote connections. So telnet is not secure as compared to SSH. So SSH communication is going on encrypted, and telnet communication is going on plain text. So it is not reliable. That is why the companies are going to suppose you are going to do the Linux machine of your operating systems of your virtual environment like VMware or the cloud or Azure environment. The Linux environment is going to access it from the SSH point of view. So your whatever the communication is going to provide the ID and password, and this is comes under the connect plain text, or you're going to say encrypted text. So 10.1.1. Suppose I'm going to do 192.168.1.1. So right now, SSH is not going to enable on the system, so it is not going to be opening it over there. So if your devices will be available, go for 192.168.1.1. It is going to be accessible from the same. Okay, so this is the common remote connections one using it. FTP, file transfer protocol. So we have port number 21 and two communication channels going to be working. Upload, download, delete, rename, everything is going to be using it. So what happened? You're in the FTP mode and then check it out the different type of commands. Okay, so we have debug, we have disconnect, we have ls, so we have different type of directories. So not connected right now, and we have SDA status. So right now status is verbose on, bell off, pumping on, relapping on. So these are the things will be coming. So you have different type of things like your get, you put, we have mkdir, and we have different type of commands. Remove directory rmdir, rename directory. So suppose you want to do mkdir and over secure. So right now it is not going to be connected to the FTP server because we require some IP address. Okay, we require the IP address of the systems. So right now this is the things we going to using into the Windows environment. But we have Kali Linux environment. We're going to do all those practical things later on. So user interface, control processes, and data transfer processes going on. And the TCP connection will be created. So FTP server is going to use for the file transfer protocol. So you have some centralized locations where you're going to save your data, and it is going to be get and port and download, rename, anything you're going to do it from there. As such, so I already stressed to you that it's more secure than the telnet. So we have port number 22 is going to using it. Inaugurations is Imap command. This is command going to using it. And working is also known as a secure shell, and secure socket shell is a network protocol that gives users, particular system administrator, a secure way to access the computer over the unused networks. So the SSH client and SSH server. So client is sending a request, sends server a public key, and negotiate the parameters of the open source channel, and the request will be sending over there. So suppose this is the system admin with the root access and system admin and the application, and they are going to use using SSH and sending to this particular server, and this particular SSH file transfer protocol sending request, and a different type of customers HTTP, HTTP responsive communicate. So this particular, all those three users are going to using the SSH for the communicating with their server and the TFTP server same thing. So it's a secure communication. We're going to be using it. And moreover, we're going to use the PuTTY and super PuTTY for to access the things like that. So this is the PuTTY software. You just, if you have time, just going to install it in your systems. It is very simple and very small software. PuTTY software, and then if you're going to log the entries, okay. Suppose you would like to log the entries of the particular thing, so you're going to go the translation. Looks like it. Yes. So all sessions you're going to put this particular file name over there, and it is going to printable output. If you're going to print all those commands. So right now none. Printable output, you're going to click on the same. So all those output which you're going to be running on your environment. Okay, suppose you have a switch going to be configured, and switch you're going to provide some command line things. So all those output, all session output will be coming same time. Okay, so it is going to be saved your all the data on the same. So we're going to do later on once we're going to do practical things, but this is the things we're going to go to the all session output will be saved into the file. Okay, let's move to. So we have TFTP server. So TFTP is a triple file transfer protocol. Okay, and this is the network protocol used to transfer file between the host and the TCP/IP network. Okay, suppose you want to sending a file from your system to different particular networking devices. So you have 5 networking devices, routers, switches, anything like that. So all those OS operating system or firmware is going to be saved one specific location. SMTP is going to use for the mail transfer protocol. So what happened? So how it's going to port number 25 working, and this is working. SMTP is a part of applications layer of the TCP/IP protocol, and using the process code stored and forward, SMTP moves your email and across networks. So it closely works on the mail transfer agent SMTP and by transfer movement. Suppose this is the client and is going to sending an email to the this particular destination. So sending an email to the server, and server is going to check it out this where you want to sending. So server to server is SMTP communications, and then it is going to sending to the Imap servers of the things. So how the things are going to be working? Suppose this is the person, and he's going to use the Outlook. This person sending an email to the specific recipient, okay, like Gmail. Okay, so this is the mail. Suppose this is me and sending an email to jayaprakash@gmail.com. This is the mail ID. I am going to using it from the Outlook. So sending request to the SMTP server, and SMTP server and the electronics going to check it out. It's our domain and it's out of domain. It's a Gmail domain. It's our company domain. Okay. Then it is going to categorize and sending the information to the SMTP server, to the Gmail receiver electronic. Okay. Gmail server, and Gmail servers will be check it out. Yes, it is from my client like Gmail domain, and it is sending the request to the recipient. So we have check it out. We have SMTP server communication going on. So we have Gmail server, and we have your web server of your company server. So company server going to categorize. Suppose it's a gmail.com, it's a hotmail.com, it's a different domain. So all together, as per the domain, is sending the SMTP server of the different company, and different companies will sending the request to the recipient same time. And suppose it's your own company, then it's sending the SMTP server to your own company employees same time. It isn't the request not going to be different SMTP server. So we have post office protocol version 3 POP3. So POP3 is the port number is 110.995. How it's going to working? So post office protocol is a set of mail protocol used to receive mails from the remote and server of the local mail. Okay, so you're going to locally going to be creating it. Okay, suppose you're going to configure your Outlook. Okay, the post office POP3, Imap, SMTP things are coming. So it's a protocol where you're going to be storing your emails. So we have Imap, so Internet Message Protocol access. So it's basically port number is 143, and Imap also allows you to access your email messages. So wherever you are, much of the time it is accessed via the internet. Basically, email messages are stored in the server. So all your messages are going to be stored on the server. Okay, so suppose it's a sender, and sender are sending an email to you. Okay, it's the client, and the SMTP server is receiving it. SMTP ISP A is receiving and sending email to ISP B, and this client is going to getting it, and the server with the client internet is going to sending this particular request to the recipient sometimes. So what happened? The request is going to sending from the SMTP server to SMTP server. Okay, SMTP to Imap server, POP3 or whatever it is. Okay, so Imap is going to connecting at the same time, and they're converting the Imap, POP3, SMTP, whatever the client is and sending request. We have then DHCP. So we discussed about some port number 67, and you go on your computer and connect to the internet. The network request an IP address. This is usually actually referred to as a DHCP Discover message. So on behalf of your computer request, a DHCP server allocates the computer an IP addresses. So you know that you have dynamically getting the IP addresses. This is what the DHCP is there. So we have DHCPs available. We have servers, and DHCP we're going to configure on the firewall. We're going to configure on the routers. So DHCP is everywhere. Okay, on your servers, specific servers you have DHCP server. If you don't have a server, we have going to configure on the routers. We're going to configure on the firewall. So we have some processes going on. So first of all, the request. This is the client, and client is going to be sending a request to the server that Discover. I require the MAC IP address. Okay, and then the DHCP is going to offer the request. Yes, I'm going to check it out. Okay, I'm checking it over there. Then this DHCP server is sending the request. I require the IP address to send to me, and this is sending the IP address acknowledge. Yes, it is Discover. So Discover client searching DHCP server first of all, and DHCP server sending an offer to the client. Yes, I'm available, and request to client to find IP address from the DHCP, and DHCP server assigns a client and send acknowledgement. So this is the client to server communication. So that is why DORA message. So suppose this particular client is not getting the IP address. So we have separate range like 169.254 type of range is going to be allocated same time until this IP address not getting it from the DHCP server. We have HTTP protocol. So HTTP protocol is port number 80 and hypertext transfer protocol is used looks like. So it is this particular HTTP is not so much secure. Okay. Suppose we're going to do the Wireshark and we're going to be hacking the ID and password to the same. It's easily. That is why we have protocol named HTTPS comes to the picture. So HTTPS, why it is this particular HTTPS more secure? First of all, is a port number 443. And suppose this is a user sending a request site. Suppose I am the user and I require the parent system. One thing I required the cisco.com or gmail.com. So first of all, it is check the DNS records of the IP address on the website. Okay, so it is going to check it out from your own that whether it's reachable or not reachable. So the request is website records on the going to be host server. So it is going to request to the host server, and the requesting to the SSL, as I said, and connection to the website. So it is the hosting servers going to check it out whether this particular request is going to be entertained or not entertained. Suppose I'm going to access the Amazon.com. Okay, so my first of all, the DNS entry is going to check it out whether the request coming going to outside or inside. So what does it mean? It means that I'm going to do ncpa.cpl and I'm going to access the Amazon.com. So Amazon.com is the outside network. How is going to decide? It's going to decide by the DNS server. So this is a DNS entry. DNS, the domain naming system. We discuss about later on all those things. But this particular Amazon.com is our internal server or it's the outside network. So obviously it's not my company network. Amazon is outside. So the DNS server sending the request to the outside clients. So the same thing is going on. The DNS server going to check it out, and this records is there. So this is not my system. So it is sending request to the outside. Okay, so this is the things that the web hosting server is going to be entertained over there, and once it is going to check it out, and then host records with a valid SSL certificate is going to check it out. Once the SSL certificate will be checked out over there, and the communication will be going on. So the matter of fact that we discussed about here some time ago that we have this particular website, and if the certificate is there, the certificate is going to find out, then it is going to be communication with the client and server. If the communication is expired, okay, this license is expired or the digital certificate is expired, so there is no communication will be going on with the particular server client systems. So we require the digital certificates to communications. That is why we have SSL traffic is going to moving it. That's what we discussed over there. So no one going to ask you all those things, but you have some basic fundamentals should be clear about the SSL, TLS, HTTPS, Igmp, all those things. We have SSL secure socket layer. So it's what Netscape in 995 purpose for privacy. So SSL basically client and server. So establishing with security capabilities phase 1, server authentication and a key exchange number phase 2, client authentication and key exchange number phase 3, and finalizing a handshake protocol. So SSL secure socket layer is basically used to communicate. Suppose this is the client and client is going to access the particular protected secure server. And server is going to say yes, I'm available and check out the CA certificate, okay, digital certificates. Certificate is stored on the client system and certificate is stored on the server. So once they going to exchange the certificates, and then the communication is going on. Why it is? Because this the client has this valid request to asking the server yes, I am I'm the client and I require this one. Suppose this is the client is hacker or intruders. It is sending the request, and if the server is not going to find out the certificates, it's going to refuse the packet same time, discard the packet same time. So what does it mean? Suppose the example is suppose you are working in a company, okay, and you are going to access your emails or you want to access your server from the outside. So suppose you have your own system, you have some VPN connection, then you're going to be providing the ID and password, and you're going to connecting it from the VPN and going to connect to the server. Suppose you are going to cyber cafe, or you're going to go any different place where there is no company laptop or there is no VPN, nothing is there. So how would server will know that you are the right person or wrong person? Just because of the certificate authority, the certificate going to check it out. If your certificate will be installed and end-to-end communication going on. So authentication is on your email and ID and password, which is happened. But how the certificates will be installing it? So with the server and the client require the digital certificate to communicate. Authentication, authorization, accounting, the three things are going on. So SNMP simple network management protocol. So SNMP basically port number is port number 6161, and it is the SNMP protocol is going to sending the informations to your server. It means that suppose you have some networking devices, network hardware, you have routers, your switches, your firewalls. So whether this particular logs and events and anything, how this particular system admin would know that whether there's any problems or not. So you're going to enable the SNMP protocol over all those appliances, and the SNMP once you enabled it, and this particular device is sending information to the server management station, and then this particular person is going to see all those packets. So, however, we are going to use some different type of uh, um, software tools like we have SolarWinds, PRTG, MRTG. So these are some softwares are going to check out the SNMP discovery going on. So what happened due to this? We require to management. We need to check it out whether it's up or down or what type of things going on, events, alerts, others, whatever. All those information will be sending to your management server. So that is why SNMP comes to the picture. Okay, we have domain naming system. So you already know that domain naming system is basically you're resolving the IP address to host to IP addresses. Why it is? Suppose I'm talking about Cisco.com. So you know that Cisco.com is very easy to remember. But I'm going to ask you what is IP address of Cisco.com? No one knows. So this is what the DNS is going to do here. So CMD, and I'm going to do let's look up. Okay, and then I'm going to do Cisco.com. So this is the IP address of a Cisco.com. Okay, so this is what I'm talking about here. We, as a human being, we easy to understand the name, but we hardly remember the IP address of the particular website. That is why your Cisco.com to this particular IP address is resolving who is going to doing it. The DNS is going to resolve all those things. Okay, so what happens? Suppose I'm going here and suppose I'm going to paste this particular IP address on the machine. This is the IP address. Copy, and then I'm going to using it here, coming here, and then I'm going to use the specific IP address. Suppose 172.163.4.185. So I'm going to use this, and this is resolving the specific IP address. So it is going to opening the Cisco.com. Okay, IP to host, host to IP address. And suppose I'm going to open the Cisco.com. So is it easily opening it right now? Okay, easily open. But we're going to resolve it through the IP addresses. Okay, we're going to just check it out, all those things. Okay, so how would I check it out? CMD string -a, then Cisco.com. So this is the same IP is going to resolve. So name versus the IP address is going to be. That's what we're going to bring it from here. So this is what this DNS command is working. Okay. So we have different type of records: host record, A record, MX record, mail exchange record, A record, host record. Okay. So the things are there. So CMD, and then we have registered DNS command is going to be IP config. Then registered DNS. Okay. So it is register DNS. Request operation request application. Okay. So register DNS, or we come to check it out. Some release renew. Okay. Release IP address, renew the IP address. So this is the command line to do. So you have free time, go for it, my dear friends. So a mail exchange record for your mailing things, a record for your host record of your system records into the DNS servers. Okay, working overview of DNS. So just try to spend DNS zone passcode. Okay, we have different number of zones. We want to be connecting. So what is DNS poisoning? So DNS poisoning can ultimately route users to the wrong website. For example, a user may enter example.com into a web browser, but the page chosen by the attacker loads instead. Suppose you are the client and you're going to write down a Cisco.com. Cisco.com is a real website. Okay. So instead of your request is going to the real website, the web server, DNS server, the intruder or hacker is going to implement a new DNS server, and your request is going to the fake server instead of going to the real web server. So inject fake DNS entry. So this the fake DNS entry is going to doing it, and the request is resolved by the fake website. So DNS servers is going to be sending the request to the fake website. So what happened? Redirection. So it is going to redirect some different website, different page. Instead of going to the real website, it's going to the fake website. So it's a DNS poisoning. So DNS is going to DNS records, because DNS have some records. We discussed about earlier that we have some MX record, we have some SRV record, we have some service records, we have transport text records. So all those entries are there. But if this DNS server is sending the request to the wrong fake website, so this is the fault from the DNS server. So this is the DNS poisoning is there. You're going to poisoning the DNS records. It means that. So what happened? This creates a perfect opportunity for the attackers to use phishing techniques to mine information, to be locked the credentials, credit card information, and suspecting victims. The attack can be devastating depending on the several factors, including the information that attacks for the DNS poisoning. So you're going to poisoning the DNS records, and then the DNS is going to send a request to the fake website server. So fake website server, suppose this client is going to be provide the debit card and credit card information. Suppose you go to amazon.com instead of you want to set Amazon, you want to change the name of the Amazon. Okay, and the records going to create into the same DNS server. So suppose client is going to write down AMOZ over Amazon.com, and that DNS server request is going to some fake server. And suppose you want to be provide the credit card and debit card information over there, so it will be hacked by the into the same times, because you all those fake entries will be coming to the different hackers same time. So working of DNS poisoning, so that modifying the DNS servers requires some crafty hacking, modifying the client host file, and the host file takes precedent over the DNS queries. So matter of fact that suppose this is the client systems and this is the IP address of the client systems. So this is the request going to DNS servers, and DNS servers, we know that this is the IP address of the particular server system. we're going to modifications going to doing from this particular DNS server over there. Domain hijacking. So this type of attack can involve changes in your DNS servers, okay, and domain register that can be directly your traffic away from your original servers to new destinations. So instead of your records going to the same server, it is going to the bad server, main server. So you're going to hijack the domain server. Suppose .com, Amazon.com, and somebody will say Amazon, different website, and then Amazon.com. So it is going to changing the default domain. So domain hijacking is often caused by a lot of factors related to the exploiting availability in the domain name registers and systems, but can also be achieved at the DNS level and attackers take control of your DNS records. So the matter of fact that you have seen there's some PayPal and Visa and bank institutions. So suppose it's a registrant, okay, this is the user, and user is sending a request to the register domain. So the register is the attacker is going to register all those registry entries going to be hacked, and the register entries will be going to some different bad server instead of going to the correct server. So once your entries is wrong, your domain is going to be bad name server. You're sending a request to the bad server same time. So this is causing the issues in demarcation. So demarc is also important. Demarc makes it easier for internet service providers, ISP, to prevent malicious email practices such as domain spoofing in order to phish or recipient personal information. So essentially, it allowed email senders to say how to handle emails that were not authenticated from using SPF or DKIM. So senders can opt to send those emails to the junk folders to have them block them or altogether by doing that. So ISPs can better identify spammers and prevent malicious emails from invading customer inboxes. So the matter of fact that suppose this is the user, this is the receiver. So suppose this receiver is sending the email to the receiver. Suppose this is the receiver says that as this is the finance head, and the requester will say that as per we require $20,000 for the company use cases. So at the same time, it is going to sending a request to this particular finance head. So at the same time, once it's going to sending an email, the phishing, okay, this is the hack intruder or hacking, hack this particular email and change the value. Okay, so what happened? The original message is going to be spam, and this particular phishing email will be sending to this particular receiver. So once the receiver is going to receive this particular email, so what happened? The particular domain is not going to be authenticated. The which domain it is coming from. So demarc is basically checking out the domain, which domain it is coming from. It's the same domain or it's not different domain. So suppose you are working in a company like we have Cisco.com. So your ID is jprakash@cisco.com. So at the demarc is going to check it out whether you are coming from which domain. It's an authenticated domain or it's not authenticated domain. Or it's a phishing or it's a spam domain coming from. So if your domain is going to be authenticated, then the mail will be received. If your domain is not registered or if your fake domain looks like, then you are not going to check it out. So fake domain checker. So we have different things will be available to check out the fake domain is there or not. This is what I'm doing. DNS paper. So enter the domain name and similar ones. So this Amazon.com we have. So it is going to check it out. Similar type of domain. So amazon.com. Amazon.com. So this is the like a fake server. Okay. So we're going to analyze. This is the servers. This is the MX record to be available or not record to be available. So however, we have some different clients out altogether. But yes, this is the fake things will become. So we identified 241 domains similar to the Amazon.com. Okay, and 182 domains are resolved in MX report. So 183 domains are correct one. Okay, apart out of 241. So we are going to identify the 183 domains. But apart from this, the virtual is left. I think 60 domains we're not going to identify who they are. So these are some fake things. Suppose this is qman.com. So it is not going to resolve. Okay, so we're going to analyze this one, and you're not going to resolve those things, my dear friends. So you will Google say browsing, check the path domains, and who is lookup domain. Okay, to form who is this the person is all about. So you're going to check it out where it is coming from, what is IP address, where does it belong to. So this is the way you're going to check it out, the fake domains. Fairly likely 57% they direct to Amazon.com. And Google say browsing, what's it suggesting it? No issues detected altogether. So this is the fake website, fake things you're gonna be checking from here. Okay, so there it is. We're going to testing here. We're going to try it with your phone. Okay, that's not moving to the mark. So we also, if you go to here, go here, and suppose I'm going to access any image from my Google. Okay, so this is the project Yog. This is the project Yog or whatever. This is the email. So how it is authenticated email or not authenticated emails for what is? I would like to check it out the credibility of this email, whether the email is wrong or right or what. So go to this one and then go to show original message. Okay, show original messages. Just click on it. Once you click on the show original message, all those messages, original messages will be coming to front of you. And then you have check it out the SPF. Pass the IP address. Okay, this is IP is passed. DKIM, pass the domain place. Remark is going to be passed. So what is it is passed, and passed. It means that this is the email ID, this is the mail is coming from whatever the things. So it's not a fake mail. It's not a fake domain. So what does it mean? Go for SPF. So first of all, it's not a fake thing. So SPF, DKIM, and Imap authentication. So this is hard to protecting your spoofing on phishing on spam email. This is going to categorize. Okay. So just once you have read it, just try to understand these things. So it will going to ask you your interview, what is SPF, what is DKM, what is DMARC, and what are the differences between all those things. So please understand the definition and use cases of all those things. So I'm going to showing it right now, the use cases, all those things. Okay. So this is the message I am going to opening it. And first of all, it is going to pass everything. So it means that it's not a fake things. It's not a spam emails. It's not a phishing emails. It's the correct domain. We're going to find out all those things. So how would I going to see that? Go down. And then you have going to see that this is the source code coming from the date is also available, and then RSA this is also there into the same. We have source thing google.com is this connecting it over there. Go to done, and then it is coming from the SMTP mail server from this is the SMTP mail server. This is the mail server from the SMTP is coming from, and this is the IP address range is permitted to the sender. LE events is 104, and this is the time and date, all those things. Okay, and the destination is 204.3.1.1.1 permitted by the sender. So you have seen this particular all those things like we have domain names, PKIM pass, header is I relevance in header, postal header is there, and we have SP is also passed, and SMTP address is also there. Okay, this is the different IP address postal code is coming from all those things. Okay. So this is what we going to be see all those informations, my dear friends, and this is the contents of your email. So I would like to check it out. This is the IP address. Okay, this is so how you check it out. I already suggest you in the previous classes. Who am I? Which lookup IP? Go there and then paste the IP address and we're going to show you. Okay, so all those information will be writing. 10th floor, New York. This is the postal code. So US website and simple cloud hosting, and this is the digital ocean. Okay? And this is the phone, and this is so you're going to be track this particular IP address and you're going to find out where it's coming from where. Okay. This is what you're going to be tracing the specific IP addresses, tracing the SPF, PKIM, DMARC, and whether it is going to check it out. If it's a fake page, fake domain, or not fake domain, all those things you're going to check it out. So if you're going to provide the digital ocean, you're going to find out it's a correct website. This is all about. Okay, let's move to the slide. So this is DMARC. Okay, so we discussed also the overview of the vulnerabilities. So TCP/IP, most protocols is also back to the passive via attacks are working on sniffing. So we have monitoring traffic. So we have patching, we have lack of patch management, unmanaged mobile devices, poorly configured our firewall rules, weakened default passwords, insider privileges, misused USB drives. So these are some network vulnerabilities. So suppose you are going for the interview, or you are a network security administrator, or you are a cybersecurity expert. And the question will be coming that what are the network vulnerabilities? First question. The question you're going to say that suppose we have unpatched operating systems and applications. So what does it mean? Suppose I'm going to use my system and I'm going to check it out whether my system is patching or not patching, security things, all those things. How would I check it out? Go to update and go for the Windows update settings or whatever. This is the settings of my system. And then Windows update, go to the update Windows. And then you want to check it out. View update history. And then you're going to check it out the successfully installed. So 24/5/21, it is installed. Okay, updates will be installed. And then you're going to go there, go down and check whether it is security updated or not. Security updates, security updates, security updates, security update of Microsoft Excel, security updates of Windows 10. Okay, so my system is going to be up to date. So you're going to check it out whether your system is going to up to date or not. So if it is not going to up to date, there may be possibility that ransomware is going to become, and my data will be encrypted, and they're going to charge money for the same. Okay, the feature of Windows 10, and this is the version will be available. So I'm going to installing it right now. So to check it out. So it is going to be installed backend. Okay. The first thing is network vulnerabilities and test operating system. So this is things I'm going to check it out for my system. What about the firewalls? What about the networks? What about the systems? So you also going to check it out whether your operating system is updated or not. Suppose I'm going to provide this example. Google, and then suppose we have some firewalls. Okay, demo on it well. Okay, Sonic Live demo. So we have checked the patching things has been done or not done in my system. The same things we're going to be applicable on your devices of the application. So suppose we have 3650 device, go to the demo sessions, and then we're going to check it out whether the firmware is updated or not updated, and what are the security patches are released, whatever things we're going to check it out from here. So look at this, go to the firmware and license. Okay, this is the firmware, this is the operating system of the firewalls. So we're going to check it out further to any different devices as well. But right now I'm going to check it out the Sonic Wide. So this is the Sonic OS in has 6.5.7 and debug, and this is firmware updated on the 10/8/2020. So right now 2021 is going on, and build is this one, configuration date is 2/8/2021. So right now this is the updated or not updated the firmware. This is the you want to check it out. So this is configuration date is 2/8/2021. So we have different release or not release new firmware. You want to check it out, and then going to update your firewall from here. So you want to go down and then check it out there. So show two configuration files. We have 6.5.4 version will be available, and this is 62 and 26.5 enable. So we going to check it out whether we have available, not available. Go for the new firmware upgrade. Okay, so 6.4.7. We have three configuration files. Will be showing it right now. Go down and then check it out. This is the updated one. 29 of 5th of 21, 28, 27. So this is the configuration date is there. So you're going to always go into the firmware load date and the configuration build date. So make sure that you're going to use the new firmware latest operating systems. So once you go to the latest operating systems, the latest patches will be coming. Okay. So this is the things you're gonna check it out on your networking device as well. Go to the firmware and backups, and then take the backup first of all. So you want to import and you want to upload, and you have settings. So suppose you would like to take a backup. So you want to click on the same and download the firmware. Okay, it's going to download the firmware. Okay, and then you import and export. So you want to export your configurations. So you are going to export the configuration of your firewall. Okay, so export configurations and export, download the firmware from here, and then you're going to change the firmware. Take the downtime, change approval, and then you're going to be doing the things like that. So it's very easy. If you know the things, if you don't know, then it's very critical for you. So this is the first things I'm talking about here. The unpatched operating system notifications. Lack of patch management, the same thing is there. If you have not understand the patch management, unmanaged mobile devices, laptops, and okay, unmanaged. How you going to manage all those your laptop, mobile? You have weak passwords. You're going to the passwords are stored on the Excel file or Word file. Okay, you don't going to clean your files. Okay, so this is a number of things unmanaged. Poorly configured and outdated firewall rule. So suppose you want to outdated rules you want to creating it over there. Okay, the rules are there. You're going to create and these rules are outdated. Long time back you're going to create, but the technologies and the internet is going to be changed sometime. So this is what you are going to facing some lots of issues. Okay, so right now this is all to all. I'm going to say LAN to WAN zone. So your LAN to WAN zone, any, you're going to allow everything. So suppose you're going to say WAN to LAN, okay, WAN to LAN, and then you have to check it out, deny action. Okay, so make changes all those things. Traffic coming from outside to inside, inside to outside, and check the rules. So right now it's working fine so far. So this is your poorly configured out of the rules. Weak password, default password. So we already suggested in our previous sessions that if you have the weak password, default password, please change everything. So the weak password, default password, and user is going to go for the default password things and going to provide ID and password. You won't do anything. And you are inside the privileges like USB drives, print, screens, optical, media. Somebody going to use a USB drive at your home. Okay, so this is impact of vulnerability. So we have what type of impact do we have? Escalation of privileges. So an attacker exploits this vulnerability would assume greater privileges on the compromised systems, allowing them to potentially destroy data or take control of the computers and malicious purpose. So this is the elevation of privileges, escalation of privileges, information disclosure. Your confidential information will be vulnerable. Denial of service. Your system will be enabled. Okay, DDoS attack will be happening. Remediation management. How you want to remediate all those things? So you want to user policies, create network access policies, remote access policies, wireless policies, network management policies, server policies, IDs, IPS, DMZ, regulatory compliance policies, corporate policies. So all those the security policies you want to be creating over there. TCP/IP vulnerabilities, so TCP/IP vulnerabilities or the vulnerabilities, sync flood attacks, DOS, DDoS, code-based vulnerabilities, management attacks, sniffing, ARP sniffing. So we have sync flood. So a sync flood is a common form of denial of service attacks, and that can be target any systems connected to the internet and providing transmission control protocol. So basically, suppose we have three-way handshake, you know that very well, TCP. So your syncing is going on to other systems, syncing them. Sync, act, and acknowledgement. So the intruders are going to be sync flood, okay, flooding the different type of syncs will be happening. So a sync flood is a type of TCP state execution attacks and attempts to consume the connection state tables present in many infrastructure components such as load balancer, firewall, integration, and application, things like that. So the number of requests will be sending to the receiving end. We have sync flood attacks, how it's processed. So suppose if you have seen that in the Amazon.com or Flipkart.com, the website, the marketing website, they have some offers. Suppose the companies are say that we have offer and the offer will be available tomorrow at 2 p.m. and going to be check, you want to be collect this particular Redmi 5A within 5,000 rupees. So at the same time, 12 p.m. on 14 December, the traffic is very high. And once the traffic is very high, the possibilities that the hacker is going to be access all those resources and sync flood will be happening because number of requests will be going on with the server and servers we don't know how to do it, how to handle all those requests. So at the same time, the hacker is going to sending the request, sync flood, and then going to acknowledgement all those spoofing attacks. Denial of service attacks. Denial of service attacks means that suppose you have web servers and the user is going to be getting request, but the attacker is going to be denial of service. this particular web server is not going to responding something. Or the intruders are going to be shut down the servers, and then our service attacks has been done. Service will be destructed. Okay, so all those things has been done by the attacker. DOS, where DDoS attacks we have denied, or service attacks will be happen. So victim servers going to be denied from the different websites. Code-based vulnerability, so we have overswept top 10. We're going to doing it in our application security things later on. Man-the-man attack, suppose the user is there and user sending a request to the web server, but at the same time the session will be hijacked. The new connection will be connecting by this particular server. Sniffing. How do you sniff information? Sniffing is a process of monitoring and capturing all packets passing through the given network. Suppose this is the victim, this is the web server, and this is the attacker. The victim is sending a request to the web server, and the attacker is going to sniff the information. So it's bypass the information sometimes. ARP spoofing attacks. So suppose this particular attacker is going to change the MAC address of the system. The switch and this particular server don't know the traffic coming from where, because they don't understand the MAC addresses. The MAC address is going to be changed and then sending a request to the system. So we have social engineering attacks. So we discuss about some that. Suppose you are on the social engineering, like you have Instagram, Facebook, Twitter, okay, and all those information going to be leaking from there. Your mobile number, your email address, everything from there. So the example, honey trapping attacks. So we have 50 soldiers, honey trapped by Pakistan agents, Jawan arrested for leaking sensitive information. So they are going to be, leaking information from India to outside or geographical locations or whatever military entry informations, because they don't know they are trapped from the Pakistan agents. Phishing attacks is the most common type of social engineering attacks of occurs today. High level, most phishing schemes and three things. So personal information such as names, address, and social security numbers going to be leaking from the phishing. Sending phishing emails, anything, then going to back. Homographic attacks, basically homographic attacks are those attacks that this is the Apple site, www.apple.com. Somebody will going to send and site is APPLE.com. Different. Okay. So here you will say A and AN look almost identical. They are two separate characters as far as computers or domain. So you have seen that we have APPLE. This is a different type of A. And this is a different type of A. Secure connection, but it's not a secure connection over there. Okay. Suppose I'm go there and to the here, and then I'm going to go to the any website. Okay. Suppose this is my website. So whether it is a secure or not secure, I'm going here and the connection secure. Okay. Secure connection is going to show over there. So I want to say that this is a secure connection is there. It's a correct website. If it is not coming secure connection, then it's a fake website or anything issues will be there. Smishing attacks, you will going to receive an email or messages from somebody else, and you're going to click on the same, and then you're going to be trapped. Phishing and spear phishing attacks, so your emails, you're going to getting it and going to responding same time. You're going to message and you're going to be getting all those things. Free texting, suppose this is the freedom mobile issue to everyone. You have to click so many times, and then you're going to want this particular mobile. Okay, so this is trap same time. Biting, so biting is many ways similar to the phishing attacks. So songs.pk, okay, this is for the songs listening website. So the victims are going to be same type of malicious code going to be inside a particular link. Quid pro quo, suppose basically similar to the biting. Quid pro involves hacker requesting exchange of critical data or logging credentials to access server service. Suppose your hacker is going to call to any person and going to say that I'm a security consultant for this particular company, and I will require your ID and password and login details to check your issues. So same time the person is going to provide, and then it's going to be hacked. Tailgating, suppose the person is going to company, and in the gate, the another person is going to the same time cross the gate. Inside the threat attacks, so we have some different type of threats. Attack profile, we have some 59% to 50%, 40% are inside attacks. So email security, you want to check it out, the copy clipboard, the same things we have built right now. Okay, target panic attacks. So we have different type of targets. We have contact numbers, we have phishing mails going to doing it, or social media attacks, and we have reconnaissance, recognizing this thing from doing it. Multi-factor authentications is three-factor authentications. We have mobile OTP to coming in, and OTP will be coming to your email IDs. So we're going to do practical for MFA later on. Email spam filters, we discussed about spam filters, SKDM, PKF, and firewalls. We have separate classes. We're going to doing it, no problem with this. Host-based firewalls. So we all type of firewalls we're going to doing it later on. Okay, port filtering, everything we go to doing it later on. This is preventing mitigation. So all those things we're going to doing it. So remote connections, RDP connections, authentications, very easy. This is the protocols, tunneling, VPN. We're going to do concept, different concepts we're going to doing it. IPsec VPN, we're going to do practicals. Don't worry about it. So things is covered right now. So VPN, firewall, network security, Nmap, all those practical things you want to take it so that it's very easy for you. Suppose right now we have firewall is open, and we're going to go to the VPN, and we're going to create some different type of. So we have going to do separate class for VPN so that it's a very wide and very big. Everyone is going to ask the VPN, MPLS VPN, side-to-side VPN, different type of VPN. So we're going to discuss the SSL VPN, MPLS VPN, side-to-side VPN, remote side VPN. All those we're going to discuss a separate class. Use cases of VPN, everything. So your assignment going to be network vulnerabilities, find it out and send me reports. Okay, this is the assignment for you. Any questions you would like to ask me regarding anything?
No, sir.
Okay, thank you very much, guys. I already shared this particular PPT to you yesterday. So any questions, let me know. And we have separate topic for tomorrow. We will going to discuss. Thank you for your time and keep healthy. Take care of yourself. Thanks.